How's it going, everyone? Welcome. Euler Gonzalez here. So in this video, I'm going to explore now the using the scoping and closures and why this is important and relevant, right? So over the couple past videos, I went to explore is first the social aspect of JavaScript, things that live around the language that is not specific, or the technical aspect of it, that is why the name of JavaScript and who made that, who now owns the legal trademarks, and who oversees the technical details of the spec, which is this TC39 group. What is the role of this group? What is the process for a particular feature to pass or works all its way up to the top until it reaches the spec, which is a particular process that they have now, from 0 to 4 phases. And why do we care about that? Because as we understand when we can run JavaScript in different contexts, whether it is on the browser or in different environments, to be more specifically, whether it's on the browser, the server, light bulbs, or robots, right? The only reality that matters for the spec is the web. And because the language wants to provide backward compatibility, so applications written in specific point version in time, whether it is written in 1995 or 2008 or in 2025, they still work as expected. So they don't want to break the web. So that's the motto of the TC39 group. And to do so, we look at what a polyfill is, which is a way of how you can provide now these particular features to all the browsers to guarantee now the feature works as expected, or not only for all the browsers, but also for new features that browser hasn't supported yet, and you want and need to use that in your applications. So also to understand is a different way of how we can write our programs, whether it's an object or a procedure and a functional. So JavaScript allows to do that in each one of those realms. And the other is that as we explore more about how the language works, we looked at this behave not as a scripted language as it was in the beginning, but more like a compiled language. Not in the way of how the code is distributed, but how the code is analyzed. So, because when you look at syntax errors or some early errors or hosting, so now the language behaves now as a compiled language with this analysis phase or parsing phase, rather than evaluating our code one line after the another. This is an observable behavior. We can look at the JavaScript engine, right? Not only at the dev tool, which is not an JavaScript spec compliant, but also when you evaluate your code in the browser, for example, using a script tag or a script type model tag, right? And as we explore that JavaScript, the concerns around is that it might be a slow language. So engineers back in 2011 at Mozilla, they show off that JavaScript is indeed a fast enough language. It's a fast language because they pour now an Unreal Game engine into the browser by creating now a subset of JavaScript that targeted specifically to the engine and notify is optimization that needs to be done, right? And then years later, a group of engineers as well as Mozilla. So they want to take things a little bit further and say, hey, what if we want to have a meter representation, a language that allows to port is any of these applications written in C++, Java, Python, or any other programming languages, and run this in this new environment called the WebAssembly, right? So WebAssembly now is a it looks like an assembly language, right? So by skipping the parsing phase, when you don't have the language or the engine, the WebAssembly, since it doesn't have now this high level words or keywords that are looks like more to how humans might write application, but more like a efficient programs work in these architectures, all right, by moving register here and there, right? Like an assembly language. It turns out that by removing that parsing phase, of course, your code will be executed way much faster in this particular environment. So WebAssembly is not an attempt to replace the JavaScript. It is now a universal compiler target. So I mentioned this is just as a segue, an important segue here, that WebAssembly indeed is this part of the ecosystem, and it borns as a concern of the JavaScript, if JavaScript is a fast language or not. But it turns out that because JavaScript in itself, it was written to be a huge optimized engine or language, right? And as we now, it from the beginning, it go from a toy language that provides out silly animations and interactivity to the user to a language in the standard that is being used now by applications and corporations, where they now bet on, so they have their own business now in the hands of that, the hands of JavaScript, and developers now they are facing challenges that they haven't before. So in order to guarantee that the JavaScript language now is optimized and performant, so the user strict comes to the language as a way to tell the JavaScript developer to follow this practice or these rules that has a good chance of optimizing the JavaScript engines, right? And this one of those rules in the use script is, hey, let's go into when you have now a identifiers, when you have the same identifiers in the function parameter list, right? Instead of just silently let it go, right? So you have parameter names. You have parameter names. You have multiple parameters with the same name in that function. So instead of not doing anything, so not notifying that, and then you're starting to trip around if this value is the same as this another one and how big JavaScript behave. So it's going to throw now an error in the user string, right? As well as additional early errors. So for example, like you can have a function known with the name eval. And I do think this is also true for arguments, right? So this is just the ecosystem around the JavaScript And then when we look at the more technical aspect of the language, so for example, understanding is what a program is, how JavaScript see programs, how JavaScript now execute programs, how you can make these different programs, aka files, to cooperate that, right? And then understanding that when you're creating your programs, working with variables and understanding variables is one of the most important things that you're gonna do, uh, because those values represent is now a state of your program at that moment in time, and it can be is, well, a number or a string. A number and a string follow a particular format as a way to represent is to the machine, this is a number, using is the IEEE 7053. I do think the IEEE, the IEEE 7054, exactly. All right. Which is part of the standard that say, hey, this is how we're going to represent is floating point arithmetic, aka let's going to take now and represent, let's take this spec and see and apply that to the language to follow that, right? And then you also have is the string that back in the old days it follow a particularly way to map symbols to a number, all right, known as ASCII, right? Because it used now 7 bits to represent those numbers. But it turns out that fell quite short, because not only to represent is a English character set, but also when it comes to represent other symbols in other languages. So, for example, Spanish or French, Portuguese, and I mentioned only the Latin language. And also, you need to include is, for example, is Middle East. Middle East languages, an Arabic language, right? So, for example, Farsi, and sorry if I am not dive deep into that, but Farsi is what I remember the most. But also is hands-based character or Chinese character, right? Or Mongolian characters. And this Chinese is or hands-based character is like Japanese and South Korea and in China. So I mentioned this is because now this new format, or this universal transform format known as UTF or Unicode, is a way to actually represent is all of these characters from all of these possible alphabets and symbols across the humanity, all right, and then put now a number to it, right? A 16-bit representation of that. So anything that falls into these known symbols, right, is known as the basic multiplane, a basic multilingual plane, right? This is basic multilingual plane, right? That go from 0 to 65 536, which is, in other words, is 2 power 16, right? Which is 2 power 16. Let me say is from 0 to 2 power 16. Exactly, 2 power 16, right? And this is known as what is this? The Roman of Unicode MVP multi-language. Oh, that's interesting. There you got it, right? So as you can see, is 00 represent is Latin, and then now you have all of this, and on the reddish color, it is the Middle Eastern and South Asian script. That's very interesting. There's a French, there's a lot of that. So I do think that yeah, is this one Middle Eastern? Yeah, is this one Middle Eastern? Or no, is this one Seiji key characters? Seiji key characters. What is a Seiji character? Seiji key characters. Meaning. Oh, it's a collection term grapheme used as a Chinese, Japanese, and Korean writing system. Holy hell. Okay, Chinese, Japanese, and Korean characters. So it is huge and extent. So they already have a wide, a wide way to describe the world, right? Holy French toast. And then you got it, right? The UTF-16 surrogate, which is to indicate that this is now a combination of this character. But again, all of this is to describe if the possible characters in the humanity, all right? And anything that go beyond that and is known as the astral plane. And this is what we found is, for example, certain new emojis and composition of those emojis. So yeah, I don't want to get lost into the detail here, to focus our attention on what it is important on the programs and working with variables and understanding why values are important in the language, because what they allow us to do, that represent is the state of the application. And also is to understand the different values that we can have. So for example, primitive, whether it is the numbers and strings, also booleans, symbols, big int, kind of undefined or emptiness. So for example, like null and undefined, as well as objects, which is the way how you can represent now structured data, whether it is like a hash map, like a table with key and map, or as a collections of objects, as an array, or as a function, right? And because functions now are part of a values, we look at how can we define those functions, whether it's a function declaration and an expression, what is the subtle difference in there, and also understand how you can work with these values, so you can operate with these values. So for example is values like how you can now compare two values if they're the same type or if they're not, and what is doing, what algorithm is following when that happened, what this is known as the abstract operations, and how now you can convert to one type to another type, or one type of value to another one, known as coercion, right? And then, well, understand now is how we can organize our programs, whether it is in a function or in a model using EX6 models, or as a class, right? And then go into the lower level details right now in the language, that is how do we now is deal with repetitive task. All of this is in the synchronous aspect, right? So when you have now is the way of iterating collections. So for example, like iterators in the iterator protocol and the iterator objects, okay, and understand the properties of this value, like functions. All right. So for example, closure is one of the properties, as well as the value of this, and the other is the properties of the functions or the objects, right? So for example, the prototype change. All of this is just to describe is the foundations of JavaScript, at least from the synchronous perspective. Because when you have to deal with asynchronous nature that go beyond, of course, of this chapter and of this video, and I just briefly mentioned that, is that when you see yourself in those scenarios, there are now a special type of objects that allow us to handle that, and how we handle that before those objects exist. So for example, with a callback, which now we pass a functions to a function call, and by the time that that function is executed, well, we pass now a reference to this function, so that function at some point in the future will be executed. This will be now the callback, right? The callback pattern, right? And it turns out that there's some caveat of that, not only in terms of how you define your code, but also in how lengthy and verbose, in that it doesn't allow you to is because it now introduces some coordination problems, and that is how you now respond to values in time, and then you, as those values as those values arrive and a different X amount of time, how you now update that, and then you sort that and present that in the proper order that they were called, right? So all of this kind of coordination is quite involved if you only rely on callbacks, right? And that's where we look at another particularly feature known as thunk, that this thunks allow us to hold is a reference of this function, and by the time that that function is now being called, we can is runs that. So this thunk here, and again, I don't want to get it lost to that, but thunk say, hey, I would like to define is now a function here, all right, that at some point I would like to call it, right? And they say, hey, right? And when I need that, all right, so for example, if I'm going to call now let me see, this is clock. Let's create a thunk in JavaScript. I don't quite follow. I do know that we can is hold a value as a reference, a function as a reference that will act as a token here. Exactly, because now is doing so. So in this case, so it's a that, right? So we can say is, let me create now, let me call this function and say a at, right? When you're gonna receive an X and G, right? And I wanna do is now X plus G, right? So what I'm doing is holding now is a reference of this computation that I do want to later on call it, all right? That at some point I do want is later on call it, right? At some point in our program, this will not be exactly, yeah, that's not valid JavaScript, but at some point in our program, you will now have a thumb here and call this here, right? So you're going to now, you are deferring computations by holding this as a value here, and at some point in time, in a different portion of your programs, then you can execute that function, right? And this is not only powerful for this, but it's also for any asynchronous operations, right? Because what you can do is to say, hey, when that async function comes, I would like to now is patch to this when I'm going to receive that, right? So a thumb that returns another function, for example here. This is typically with Redux. When you say, hey, let me now wrap this function to defer this computation, and by the time that I call this function, I'm going to now execute or dispatch this as it is. So, but in any case, the problem that thumbs solve is that now we don't have to calculate is the time to execute a function. We just hold a reference to that computation, and when the data is available, then we can apply to that. The name is quite confusing, and I don't know what they're smoking back then, what they call thumb, but it is right. And then we have now is an approach that comes from the language, the Erlang language, and one of the TC39 people actually propose and make that available to the language as a standard of how can we deal with single eventual values, all right? And that is, well, with promise, okay? That at the end of the day, promise behave pretty much like an event, so waiting for an event, all right? So you are subscribing to that data when that is available. And then the inner mechanism of the promise is when the data is there, you don't have to worry about the coordination of that. You don't have to wait. You don't have to create your entire logic to coordinate that data is there, or wait for that data to be there, or control is if the data that you receive is now in the proper order that you call, right? So all of these are being handled by now the promise, and the only thing that you're doing is by the time that you have a promise here, all right, with the reject, with the response and reject, all right. So by the time that you have this, okay, when you create now a new promise here, and then you say, hey, I do want is to return is the set timeout. In this case, say set timeout. This is gonna return is a number, right? But I do want to do is this, right? I do want to return now is a response that say, hey, what up, world, right? What up, world? After 2 seconds, right? That's what I do want to return. And oh, I put it yeah, is here, exactly. There you got it. Okay, so I create now this promise, and I'm gonna hold this reference of this promise here, and when I call that, Okay, when you have the value, I do want is to now is pass a functions to actually show that, right? You can say, hey, um, we can use this an arrow function in this case to say, hey, we got the data, and the only thing that I want to do is just to console log that data, right? So after 2 seconds, you get your value as it is, right? So this is now, again, go beyond the scope of today's video, but the whole point of this is to describe what is this doing behind the scenes and what is the value that we're getting by using is this kind of built-in objects, and what is the problem that they are trying to solve. And not only that is because as you can see, you can have multiple subscriptions, as we can say here, uh, and they now change multiple computations uh, when that data, we can change multiple computations and then perform is a series of asynchronous call, right? Whether it's to call a database or to call another service, Google Analytics, so on and so forth, yada yada. So you get the idea. And then once it responds, where you're gonna get them here, the same as it is, and so on and so forth. So now this behave now a mechanism to wait for the data to be complete, wait for an eventual value to be there, and then is now provide a control flow mechanism as well. This is a very powerful concept here because you don't have to manually do that for yourself. And that's a huge improvement. So because this can become is not only quite verbose, but also is indirectional, right? Because if you have now a promise here, and if you have now code that lives in other part of your program and you want to inject that, so now you have to go to that file, what this file is doing, and then go back to the promise to read what's happening next. And if that promise here is calling is another function, you have to go to that. So you have now this indirect problem here. You have to go into that file and go back here. So in order to prevent that, we have now a thing called generator, that is the logic or the mechanism that is using, for example, async function, that it allows us to define is computations like an synchronous style, right? You can say, hey, I wait for this function to be completed, and once you have the data, I do want to assign that to a new value here. You say response, and then once you have now your data, I do in the response, if the response now have to do some async operations, for example a JSON, so now I can is await for that data, right? And then store that inside of a variable and do something that I need to with the data, right? So data console log the data here. So in order to make this actually to work as expected, not as a pseudocode, but actually so you can see the power of the generators is that generators allow us is to by using is this syntax is to create now a scope, create now a function here. This is called a generator. I'm gonna call this here generator, right? That we're going to now wait for a asynchronous function. In this case, was going to fetch now some data from a type a JSON placeholder, for example, like this, right? This is an API to test your. This is a testing API, right? Where you can fetch some data, and instead of using now the await, I can say now I would like to yield this, right? In other words, I would like to now is yield this data or yield this. In other words, is to pass control, because what function generator is doing is allow us is to pause the execution of a function and then resume at later on in time the execution of this program, right? So in our case, because we want us to do this, right? And in order to make that happen, we want to, for example, create these async functions to say, hey, because I do want is to run this asynchronous operation, right? And then somehow get into the function execution here. So in order to do that, right, I need to is not only to define this yield operation here, but also is to help a reference of this object, so I can now is get into the function execution and get out, right? So to do so, we can now assign this into an iterator, iterable, or iterator, and an iterator, right? And this iterator, what allow us is to hold a reference to this function, and I call this iterator because pretty much like when you go to one each element into a collections of elements in an array, right? When you go one next to each others, we want to do that, but now is per function, aka we want is to go to this function, execute the set of instructions until a certain point, and then go back to where we are, and then at some point in our programs resume control and continue to evaluate the set of instruction until it until a yield happens, right? And return control to where we go, to where we are, and so on until there is no more instructions to be evaluated in this function. So in other words, as a way to do this will give us now an iterable, right? That this iterable is something like this. Right? Because exactly. So because now the iteration has followed the protocol of next, okay, and next is when we call this function and we provide now this data to this, all right? So we can say is yield the data, okay? But somehow we need to call is this function here. So by the time that we call the first iteration here, right? Um, with the data, we're going to now is called iteration.next, all right? Or in this case, we'll call is this. So you're gonna call that, and by the time that you have now the data available for us, I do want is to now is send the data to that, right? So send the data to the iterator.next, right? And the iterator.next will have now is the data here, so we can actually console log this to say, hey, this is now the generator as well as the data, right? Generator data, and it say promise failed to fetch, refuse to connect because it violates document security policies. Really? Oh, oh, I do think this is because I am in GitHub. Yeah, I am in GitHub. Yeah, that domain is actually scared of doing that. It says refuse to connect to JSON parsing because it violates the content policy security of the self. Fetch API cannot load JSON. Refuse to connect to security that. So if I remove this, that is quite interesting. Okay. I don't have this kind of problem with Mozilla, because Mozilla is not that scared of the users. Exactly, because and I do get it, because Mozilla is not scared of the users. Oh, it's because I do need is to call that. Exactly. There is no identifier there. Okay. Let me see here the async. Not this one. It is more like this, a sync and away example. Exactly, because I do need to yield that. Oh, it's because here I'm creating is the flow. Okay, makes a lot of, okay, here I'm creating is the flow. Or you can say flow. Create flow. Okay, if you create now the flow as it is, right? Mhm.
Welcome.
Mhm. It's because here we are creating is the flow. And what the flow is, uh, that I do want to get into these functions the first time and runs that, right? That I do want to create, that I do want to, okay, here we are creating is the flow. That I do want to run this function, okay? That I do want is to now run this, okay? In other words, it's like yield this, and by in the keyword yield, keyword in JavaScript, right? The keyword yield in JavaScript is as a way to pause and resume the generator function. Exactly, pause and resume. Pause and resume the iterator protocol here. Or you can pass as an expressions to that. And you can pass now is an expression to that. So if you can pass now an expression to that, right? So by the time that you now evaluate these expressions, you're going to yield that, and I do want to hold is the data from that here. So yield it's saying, hey, operator is used to pause and resume a generator function. So in other words, you are passing control to that. Okay. So yield this. So you are passing control to this. And okay, if you're passing control to that, uh, the question is that how that fetch feature actually going to call that again you back, right? How that is going to call you that. In cons, uh, hmm, exactly. In cons is the data of the response of the. Or let's go to do only like this, right? Console log here of the response. Okay. So here we are creating is the flow that I want to get into the function execution. And then you're going to return this. Okay. Holy hell. So we're saying is, hey, I do want to now have a value. So when I call this, so when I create flow, right? It's going to have now, you're gonna give it to me is now an iterator, right? That this iterator will allow me to is now have access to that. So by the time that I call the iterator here, all right, and I extract the value of this, the first time it's gonna pass control, and it's gonna give it to me is this reference here, is this expression here, which is the future value, right? So since this future value now is there, right? So by the time that I call this, future value, because I'm getting is a exactly, because I'm getting is the I'm getting is now this future value, this future reference here. That's what it is, because now I'm, in this case, is this is iterator dot next dot value. So by the time that I get that data there, then it's going to call the future value, and well, now call that or pass control to that, and then pass control to that, function here. Because with this function generator, what allows to create is flow. How is the execution of this? The flows, or how these generators will allow us to define is all of these different features. Is allow us to get into the function execution and then get out, aka in this generator we're going to define is the flow here. The flow here. So we got now the data, and then also and by the time that we got the data, I'm going to is now get into that. How so? Well, by calling the value again, and then pass the data. And in this case, it's doing something like this. Okay. And then as you can see is that, right? But what happened here is that the plumbing is outside of the generators. And here we are not able is to describe is the async and await syntax with the yield, because at the end of the day, here these generators in this context would allow us to define is the zero substep, is the flow of our application, and behind the scenes doing all of the plumbing for ourselves. And I know this go beyond the scope of today's video, because the focus of this video is more about on Chrome is scared to death to make any HTTP requests. This actually works in other browsers, for example like Firefox. It allows me to do so. Refuse to connect because it violates the following content security policies derived from content source, Chrome resource, right, or Chrome theme. So fetch API cannot load JSON path, and I do get why they have that, right? So the virtual machine or the JavaScript engine say, hey, no, I won't do that for you. I won't do that for you. That's what it's telling you here. So, but in any case, so as I explain that, right, and the nature of asynchronicity and why before going into this, the only thing that we care as a way to organize our programs and why this is important, the same as handling is with asynchronous data, is when you are when you are offering your services to any company, most of the time you're gonna inherit a lot of these code bases, and those code bases can be they might follow the best practices, all right, or they might be a code that look the same like all good code will look like, right? Because there are several decisions and patterns that happens there. But it turns out that uh, in order to understand now how those programs work and how we can organize our program and to understand why people before us actually write those programs as it is, well, it is useful for us to understand the scope, all right, and what the scope is. So again, I'm not going to dive too much into the scope. I just want to get into what the life cycle here, the closure life cycle and garbage collection is. And to make another quick recap, yeah, because I'm gonna make quick. I'll make it quick. So scope allows here is to understand is when we look at JavaScript and how now it behaves, not as a interpreted language, but as a compiler language, is when it evaluates certain stuff. So for example, is early errors, syntax errors, and hoisting. So because functions are a value that can be held in variables, and the relationship between functions and block, when you put in variables inside of that, is that how now the language recognize that those identifiers belong to that particular scope is thanks to the scope analysis, so the scope structure, which is determined is at compile time, at parse time, right? And because this scope structure won't change at runtime conditions, when you define your functions and assign that to a variable, and you inside of this function define variables or reference to outer variable from the outer scope, right? The scope structures will remain. So in order to understand now what the function and the scope and the block scope works, is by looking at the work, is by exploring is at how the function works, how the blocks works, also how now function names or arrow functions and even parameters create its own scope, okay? And understand that there are other different scopes, for example, like the global scope, and what the scope at the end of the day allow us to, which is act as a place where we can put all of this different functionality and therefore cooperate amongst them. So in this landscape of global scope, we can now is have different global scope depend on the place where we can run JavaScript, whether it's on the browser, which is now known as the window, and how variables and functions behave, they're gonna be attached to the window objects. You can also do now global shadowing, which is also true for variables that you define with the same name in different nested scope, whether it's function, block, or global scope. Okay. And also another environment like the uh, service worker, all right, with self, that it behaves the same. Let incomes they not attached to the global objects. The other is the model pattern, or the ES6 models, where you don't have any top level global language here, right? And in fact, you have is a var functions and let in cons. You can have access to that. There's no notion of global objects. And the other is similar to Node, okay, or Node, which is another environment, with CommonJS, which is a way of how you can organize your code prior to the ES6 model. Here we can now inject variables here that allow us to that allow us to have access to those features when the code is executed. So for example, in the CommonJS, when you define a function, you can define or a model. It is like wrapping that file into a scope like a function, and then injecting a certain dependency. For example, the name, the model. There's another couple ones, right? But each independent files, because ES6 model now follows the what the ECMAScript says, is say, hey, this is now an exclusive scope, right? That this scope has now an internal property known as the outer env that is pointer to the global object, right? So this is why you can have access to the global object primitive, as well as function constructor. So for example, like an array, map, sets, proxy, and also the variables or the property of these objects, like the global this. So I mentioned all of this is just to understand now what the scope is. What is the reason of the scope to exist? Okay, and then now see how this how the scope works with this variable syntax, whether it's var on functions, which is they host, is known as hosting, in the let and cons, which is per block. And the reason behind that to let and cons be allowed to exist, and that is that it is quite problematic to have several identifiers or variable names equally in the same scope, and then you somehow now assign a new different value to this, which leads to some problems and bugs that are hard to spot on. So that might work with that, of course, is something that with var you can do, but with let doesn't allow you to, and it is per block, not per function. And also we look at how now the let and cons behave when you have a reference before it is declaration, which is known as the temporal dead zone, and how to avoid that. And also how now var and functions behave in looping iterators. So for example, like while, for in, for of, and the traditional for, how now let and const behave that. And we look at the particular issue of understanding is the let and why using a var instead of a for of loop is something that is problematic and you don't want to do so, because this is now when a concept called closures happens, right? And you not creating is, so you're not passing is a value, you're passing is a reference to that. So in other words, now in order to understand now the scope and how the variables and functions behave in different scope, whether it's function or block, and similarly with let and const, right? We also shift our attentions to a more high level thinking, uh, because there are decisions that needs to be made and patterns that are right that needs to be applied to our programs as a way to organize that to make our application more easy to maintain. And one of them is that if you have the bigger the scope, the more likely is to have several problems. So for example is name collision. That's clearly. The other is that those reference, if you expose that and somebody with good or ill intent now use that with a different purpose, it make your application in a wonky state. All right, it makes an undesirable state. So if you're exposing now for example an array, all right, in that array now, yeah, in that array, for example, let's say you are exposed now a collection of integer values, and then down the scope, somehow actually use that reference, thinking that is a boolean values or a string value, or even it transform that with a shadowing this, because that's he might need to do so. It may lead your application in this undesired state, and the other is exposing unintended dependencies. So both of these problems, or from these three problems, name collisions, unintended dependencies, and unexpected behaviors. The unexpected behavior can be solved by using TypeScript, right? The second is with the unintended dependencies. This can be solved by versioning your application, but the name collisions remain, right? So, and also in order to make your application robust, right? Exposing the least amount of variables in a particular scope is the goal here. This is also true, for example, if you want to make your applications robust, to say, hey, or your overall system robust, is to say, hey, let's apply is the principle of least privilege. When you provide is the bare minimum amount of rights to users so they can have access to your system. So if, for example, is several of these models to now guarantee that the overall system works as expected, right? Of these all models, the idea is that connect them with the bare minimum capabilities, which if one of those models goes wrong or misbehave, well, it won't compromise the overall system at all. So a good example is that if I chop off my finger, God forbid, and then that won't compromise my overall human body. Even if I get lost my forearm or my arm or both of my arm. So the more pieces I get the more part I lost in the process, God forbid, the better off, or uh, the more part I lost in the process, again, God forbid, the more compromised my system will be, right? So that's the whole thing of here. So another topic is the closure. So with closure is, well, that at the end of the day, sometimes you need to use variables over time and continue to have access to those variables in a particular scope, specifically in a function scope, even after that function that you invoke is run in a different part of your program. Okay? So the TLDR of the closure is that a function must be invoked, a function must have at least one reference to a variable from the outer scope, and this scope can be is not only function but also block. All right, and they must be invoked in a different branch of the scope change from the variable. Okay. And here we look at the closure, lifecycle, and garbage collection here. Since closure is inherently tied to a function instance, it is closure over a variable lasts as long as there is still reference to the function. If 10 functions all close over the same variable, and over time 9 of these functions reference are discarded, the lone remaining function's reference still preserve that variable. So once the final function reference is discarded, the last closure over that variable is gone, and the variable itself is garbage collected. This has an important impact on building efficient and performant programs. Exactly. This has an important impact on building efficient and performant programs. So closures can unexpectedly prevent the garbage collector of a variable that you otherwise done with, which leads to runaway memory usage over time. This is why it is important to discard function reference and thus their closure when they are not needed anymore. So for example, in this case, if you have now this manage button clicks, so you're gonna receive is a button and define is the click handlers, and you're gonna return now a function listener, okay, that is receive is a callback. To trigger that is gonna receive that callback, right? And if the callback exists, well, I'm going to now is, okay, if the callback exists, I'm going to now is create a function and attach that functions to the event, to the button event, and add that click handler to that. And look at this, we are creating a closure here inside of this. Okay, we are creating, so what happened here is this. So it's gonna return now a function listener here, okay? Not only that this function here is describing that this is the listener, it's gonna check if you're receiving a callback, and if it is, because you define a function here that is going to call that callback with that data, all right, and then added that function reference to the collections of functions here, and then now execute that, right? if you don't receive any callbacks, so let me now is go through all of these functions reference that I had exactly all of the function reference that I have, and remove them one each from another. So go to the particular bottom and remove all of this handler as it is, aka I am releasing is the memory from this function here, and now empty the click handlers. Holy moly. Not only that this function not only that this function that is receiving is indeed creating as a closure with the variables click handler, all right, but inside of this function on click is also creating is a callback, is a closure here with the callback, an event here with the callback here, right? So what it's doing is I'm going to store all of these handlers functions. I'm going to hold all of these handlers functions to have it is reference, right? And then if I don't receive any callback, I'm gonna remove all of them. So similar for this and for this. All right. So handle checkout, right? I'm passing is now a function that this function is going to now attach to that, to the click that I'm gonna receive is the event value here. Okay, which is when I call on submit, right? With the listener, when I call on submit, I'm going to now is pass this function's reference that will be attached to the add button here on the checkout, and the other does the track analysis for analytics, right? And then later unsubscribe all handlers. In this program, the inner onClick functions hold a closure over the pass in callback. The provide event callback, that means the checkout and traction. Function expressions reference are held via closure and cannot be garbage collected for as long as these event handlers are occur. When we call on submit with no input on the last line, all the event handlers are unsubscribed and the called click handlers are empty. Once all click handle functions reference are discarded, exactly. Once all of these function reference on clicks are discarded, now the callback reference, the callback identifier, the callback variable here, the closures of CB reference to checkout and track are discarded. So when considered the overall health and efficiency of the program, unsubscribing an event handler when it's no longer needed can be even more important than initial subscription. Exactly. So you also need to find ways to not only to keep track of elements or variables that you want to use over time, but you need to also is find ways to unsubscribe to them or to remove those functions reference. So in other words, in the previous event subscription snippet, okay. So for example, if you're creating now a simple counter here, if you create a simple counter, say counter, right? If you create now a simple counter, a counter function, and this counter function is holding is a reference to this, right? With counter initially as whatever value you want to hit, say init value, right? Init value, if the init value does exist, use that. If not, let's go with 0. All right. And then let me now is return is a function that'll be called is increment. All right. And this, the only thing that it's going to do is to hold a reference to that variable and first increment that and assign the value to the counter. Okay. So by the time that I call this, for example, this is the counter function, and then I say is hits, right? And then I say counter function, and if I, let me call this here, right? And if I call hits, right? Oh, because I didn't return that. You're right. That's right. And if I let it on in the call, I call hits, I do get this. So in order to remove, in order to remove or in order to release from memory here, I need to any function reference, okay? Any function reference must be clear here. So in other words, you say null, and then now becomes a candidate for the garbage collector. Per variable or per scope. So that'll be all for this video. Yeah, take care. Bye bye.